क्या बेटा?
Very good afternoon to ladies and gentlemen. I'm Dr. Surbi Mathur, Senior Assistant Professor, Gujarat Forensic Sciences University. I welcome you all to the sixth forensic oration of GFSU webinar series on behalf of GFSU, our Honorable Director General, Dr. J.M. Vyas, and the organizing committee, and on my personal behalf. Friends, we have been really fortunate to listen to some of the very eminent forensic leaders, the best from across the globe on this platform. And today, we have once again raised the bar. Dear colleagues, we are serving a field where an error in our analysis or reporting may lead to the forensic finding lose its probative value and greater consequences through miscarriage of the justice, sometime beyond our imagination. The greatest mistake is to imagine that we never commit mistakes. Error is not a fault of our knowledge, but a mistake of our judgment, giving assent to something which is not true. Friends, Mahatma Gandhi had once said that confession of errors is like a broom which sweeps away the dirt and leaves the surface brighter and cleaner. So, our very eminent speaker today, Dr. Itiel Dror, intend to illuminate these problems and offer some invaluable insight on these issues. Dr. Itiel Dror received his PhD from Harvard University, USA, specializing in human cognition, bias, expert decision making, and learning. Dr. Dror is a cognitive neuroscientist who is interested in the cognitive architecture that underpins expert decision making. Dror research, published in over 130 research articles, demonstrated how contextual information can influence judgment and decision making of expert. He has worked in variety of domains from policing and aviations to medical expert and bankers, showing that even hardworking and competent experts can make unintentional errors in evaluating the data. Dr. Dror has worked with many agencies in various countries to minimize error and enhance decision making. Dr. Dror has received the ABP, that is Association for Business Psychology, Annual Chairman's Award for the best achievements and excellence in business psychology. He has been an expert witness in a number of countries and has been commissioned both by the prosecution and by the defense, as well as has been invited to train judges in many countries. Dr. Dror is also a member of Massachusetts Forensic Science Oversight Board, the American Association for the Advancement of Science Advisory Committee on Forensic Science Assessment, the Scientific Advisory Board of the Innocence Project, and was the chair of the Human Factors Committee of the National Institute of Standards and Technology and the US Department of Justice also. Dr. Dror is on the board of editors of a number of scientific journals, including the Journal of Applied Research in Memory and Cognition, Science and Justice, and Pragmatics and Cognition. So please join me in welcoming Dr. Itiel Dror to take over from me and address us all on this very special and critical aspect of forensic science, cognitive and human factors in forensic science. Over to you, Mr. Dr. Dror.
Thank you very much for your very kind words. I'm very happy to be here and talk to you today. Before I start, I should tell you I'm going to challenge you. So people who like to be challenged, who like to think about what they're doing, to get out of your comfort zone, we're going to have a very good time today. People who feel a bit uncomfortable, they like to stay in the small boxes and not be challenged. You may feel a bit uncomfortable, but that is what I'm going to try to do today, to challenge and to think carefully how we make decisions and how we reach our decisions when we consider forensic evidence. So to start off with, I'm going to be talking today on cognitive and human factors in forensic science, how bias can impact decision making, and a few preliminary points. We have a very short amount of time. It's a very complicated issue. Usually I spend 2 or 3 days, 8 hours a day to introduce a topic. So I'm going to cover quite a lot of materials today. And when we talk about bias, I think it's supposed to be good from the beginning. It's not intentional bias. It's not racism and sexism that you do intentionally. We're talking about cognitive bias, the way the brain works. And to understand it, we need some common background to understand how people perceive, how people interpret information, so we can talk and understand and discuss the issues. You've received a number of links already in the notices to papers in Science and other places that give a lot of background information for people who want to read more after the session. You have the links in the materials. Also, if you're interested in getting copies of the slides or any of the articles, I'm going to mention many studies, you're welcome to drop me an email. I'm happy to send you the slides and reference materials. You can always Google my name. It's very unique, and find the information also. Okay, so that's a few preliminary words. I want to start and think about what drives our perception, our judgment, and decision making. We feel that the human mind, the brain, sees the world, sees the forensic evidence, and we perceive it and we interpret it based on the actual evidence. However, even though we don't feel it, often we don't see things straight. We don't look straight, and we may be biased in our perception and our interpretation of the evidence. So today I want to give you some background on the cognitive system, why it happens, explaining what is cognitive bias, and a few terms. Of course, there are many, many more. I'm only going to scratch the surface today to give you a taster. Then to understand where the bias comes from, specifically in forensic science, how to find it, identify it, expose and minimize those biases. And then, of course, this issue depends on understanding what cognitive bias is. Often people don't understand what it is, and then they can't find it. They don't acknowledge that there's a problem, and they can't solve it because of lack of understanding, which I will try to provide to you today. And then finally, you'll have time for questions as time permits, but you can always email me later if you want to, and I'll be happy to continue and to talk to you and discuss the various issues. The bias that I'm talking about is about expert bias. So it's not only lay people every day.
Sir, just a minute. Sir, just a minute. Sir, Saifullah, sir, please off your microphones, please. You are interrupting the session, please, sir. Thank you. Sir, please.
Thank you. So the biases that I talk about affect experts, and I do work not only in the forensic domain, but in medical decision-making, pilots, police, frontline police, as well as investigating, and financial. And today, we are going to focus on forensic science, but I don't want you to think that I'm picking on forensic science. It's every domain, every expert. Okay, so what is cognitive bias? So rather than me telling you and giving you definitions, I'm going to give you examples. I want you to be biased. I want to bias you. I want you to feel it on your own skin. What is this kind of cognitive, the brain bias that I'm talking about? So I'm putting two pictures in front of you, and I want you to compare the two pictures, the two women in the image, and think how similar are their faces on a scale of 1 to to 10. 1, they're very, very different. 10, they're very, very similar. So if you look at it for a few seconds, you may want to give it a 1 or a 2 or a 5 or a 7 or a 10. You're making a judgment how similar the faces are. And that's very similar when you compare firearms or fingerprints on a lot of forensic domains, when you have to compare patterns and decide how similar they are. Now, you decide how similar they are based on the faces, but I can bias you. And we do that. We tell some people before they make the comparison, this is a picture of her mom and a daughter, or we tell people these are strangers. We show 2 pictures of 2 men. We tell half the people they're brothers, half the people they're not related. Now, the fact that you believe that they're related or not doesn't change the faces. But when we tell people they're related, your brain expects them to be more similar, and the brain sees it as more similar. So the ranking of the similarity of faces depends on your expectation based on the bias. And you can read the paper. The first few words are in Latin, talis plater, talis flut, which means like father, like son, perceived resemblance, and the belief in genetic relatedness. So if you expect the faces to look more similar, implicitly, just because you were told that they're family, you will rank them as more similar. It's not the evidence, it's not the data, it's not the actual similarity that's governing your decision making. Another example, you want to play in an orchestra in the London or New York Philharmonic, and you're judged not on how well you play. Yes, you go to an audition, and people go to audition, and they have a panel of experts listening to how you play. But these panels are very, very biased. They're racist, they're sexist, they have a lot of things going on. Implicitly, it's not intentionally, and they're all expert in music. They listen to the music, and they're impacted and they're biased. How do we know that? We've done an experiment. If you see here, there is a blind. The panel doesn't see. We've started that a decade ago. The panel of expert judges cannot see the candidate. We ask them to take their shoes off so they don't hear women on high heels. And for 10 years now, they don't see the race, the gender, the attractiveness, anything about the candidate. They only listen to the music because we've introduced that. What do you think happened? Since we've introduced the screen, the number of women in orchestras have more than tripled. More than tripled when they don't see the gender. Before that, they picked more men. Suddenly now, when they don't know if it's a man or a woman, the number of women more than tripled. And again, you can read the paper, Orchestrating Impartiality, the Impact of Blind Audition on Female Musicians. What's interesting is the judges are experts, and they're experts, they are experts, they're very confident in their judgment, like forensic examiners who make judgment, like every expert, they're very confident in what they're doing. And when I come and say to them and challenge them, look, you may be affected if it's a woman or the race or the attractiveness or if they're fat or not, they get very angry at me. They get very angry. How dare you accuse me of being biased? I only listen to the music. It doesn't matter the gender and the race or anything. So it's implicit bias. Here's another example of what cognitive bias, grave with a full skeleton with a pelvic bone, and experts need to decide if it's a man or a woman. And we've done this experiment. They get a whole skeleton, not a fragment, but a whole skeleton. So it's not a small piece. And we ask them to make a simple decision. Is it a male or a female? The skeleton I'm presenting in front of you is a female skeleton. However, before they see the skeleton, we plant an expectation that it's a female or that it's a male skeleton, so they can hear the name. This is a skeleton of John Smith or Rachel Smith, or whatever context similar to what we saw earlier with 2 faces. Before they look at the evidence, they get an expectation. Now, this is a female skeleton. They get a context. They expect a female skeleton. What happens? All of them, 100% say it's a female skeleton. But what happens when they get a female skeleton but expect it to be a man it drops down to 38%. So we're talking about a simple decision, is it a male or female, not whether it died from trauma or not, a simple decision. Now, this skeleton in front of you is a very famous skeleton. It's a skeleton found in a grave of a Viking warrior in Sweden. It was found 125 or 130 years ago. Now, when they found the skeleton, a Viking warrior, what is the image? What is the expectation? A Viking warrior is a man. It's not a woman. It's not only a man. It's a man who exercises and takes steroids, you know, the vicious warrior. Nobody imagined that a hero, a Viking warrior, can actually be a female. But in fact, this is a skeleton of a female. And this is a scientific paper that came out about 2 years ago saying, oh my God, it's been over 100 years. We're looking at this skeleton. We're all thinking it's a male, but actually it's a female. And it hit the news about a year ago, you know, in the New York Times, a female Viking warrior, or the Guardian, how the female Viking warrior was written out of history, or the Independent, or CNN, or National Geographic, all over the media, how Wonder Woman lived. The Viking warrior skeleton identified as a female 128 years after. So again, you see how the expectation impacts what you see and your interpretation. And the same goes with fingerprints, DNA, toxicology, and any domain where humans have to perceive information. When you make judgments and decision-making, you can read the paper, Subjectivity and Bias in Forensic DNA Mixture Interpretation, Reliability and Bias of Forensic Experts, Toxicology Decision-Making, and it goes on and on. And this is what I'm focusing on today on forensic examiners. But if you think that medical examiners or pilots or anybody else is immune to it, it's not. It's an operation of the brain. It's also important to note that it's cognitive bias, what we've seen, just a few examples, is unintentional. It's not like the expert people in the orchestra hear music and say, oh, it's great music, but a woman is playing, so I'm not going to let it in. Or you see the faces and you say they don't look similar, but I know they're a mom and her daughter, so I changed. No, this is unintentional without awareness. It's because of how the brain processes, and it impacts hardworking, competent, motivated people, experts who are doing a good job. It's not an ethical or motivational. It's not that people are not motivated or are corrupt. This is how the brain works. This is why we call it implicit cognitive bias. And people don't want to hear about it because they don't think they are. They believe they're objective. They get offended and defensive aggressive when you say to them, well, you know, you're biased in your perception and interpretation of the forensic evidence. There are many reasons for that. There are, for example, 6 fallacies about cognitive bias that prevent people from seeing it. It's in one of the materials that I sent you, so I will not spend much time on it. But many times when people make mistakes, instead of understanding the cognitive bias, they say, oh, this person is corrupt, is a bad forensic examiner. There are bad ones, but that's very, very rare. That's not what we're talking about. They say it's bad apples, incompetent examiners that don't know their job. That is not true. They say, I'm an expert. I've been trained. I have a degree in forensic science. I've appeared in court 400 times. I've been doing it for 20 years. I'm an expert. Experts are not immune to cognitive bias. In fact, they may be more susceptible to cognitive bias, technological protection. They think that if they use some technology or AI or automation, then this instrumentation means there's no bias, and that is not true. They see bias, but in others, not in themselves. We call that the bias blind spot. And the last fallacy is the illusion of control. They say, yes, well, I heard about bias. By mere willpower, I block out information. I don't let it affect it. You don't have control over your brain and cognitive bias. These 6 fallacies, I'm not getting into details because there are details in the paper, that in the links that you have, and you can read more if you're interested. This is in a nutshell what cognitive bias is. Why does it happen? It's because of how the brain processes information. This is the brain, and then you have the blue bars, which represent the evidence, the data coming into the brain. And the brain is a machine. You perceive, you process the information, and the brain does it. And the problem that the brain is a limited computational device. It processes information, but it can't process everything. The amount of information coming into the brain is way, way more than what the brain can process, and the brain cannot process all of it. So the brain has adapted. The brain selects information, ignores information, it changes the way it mentally represents the evidence, and all of these brain mechanisms, which of course I can't explain the brain in 1 hour, makes us not see the world as it is. We believe we see the forensic evidence the way the evidence is. No, you see it the way the brain perceives it and interprets it. There's a lot of information around you, even only in vision, and all of this gets into your brain. The eye is a very primitive component. It doesn't filter out information. It sends everything to the brain, and the brain is overwhelmed. The brain cannot take the load. You know, the load is too much. If the brain tries to process everything, it's going to be like an ass in the air. There's too much load. The brain gets paralyzed if it tries to process information. The brain doesn't want to be like an ass in the air with too much load. So the brain doesn't pay attention to everything. Now we need to start wondering, what does the brain pay attention to? What are we missing? What is the brain not encoding and perceiving in the fingerprint, in the firearm, in the handwriting, in the image, in whatever forensic evidence we're looking at? Here is an example, a bunch of coffee beans. Can you see a face between the coffee beans? Yes, there's a face right here. Most people don't see the face because there's so much information. The brain just filters out. Let me give you one more example. I'm going to put a video on of trying to solve a murder case. And people here in criminology, forensic science, I want to see if you can solve the murder. I want to pay close attention. It's a 1-minute video of who committed the murder. So I'm going to turn it on and pay attention if you can see and solve the mystery.
Clearly, somebody in this room murdered Lord Smythe, who, at precisely 3:34 this afternoon, was brutally bludgeoned to death with a blunt instrument. I want each of you to tell me your whereabouts at precisely the time that this dastardly deed took place.
I was polishing the brass in the master bedroom.
I was buttering his lordship's scones below stairs, sir.
I was planting my petunias in the potting shed. Constable, arrest Lady Smythe. But how did you know? Madam, as any horticulturist will tell you, one does not plant petunias until May is out. Take her away. It's just a matter of observation. The real question is, how observant were you?
Yes, how observant were you? So the question is, what did you notice? I don't know if you noticed. You may have noticed nothing. You may have noticed a few changes. But what happened, everything not changed. There's 21 changes. While the video was showing, we changed the color of the coat of the investigator. We changed the flowers. We changed the pictures on the wall. We changed the carpet. We changed the dead person. There's endless changes. Let me show you. And people sometimes may see 1 or 2, but the brain filters out information. So here, let me play it again when I'm zooming out, and you can see how the curtains, the furniture, everything changes during the video. So now I'll play it where you can see the changes because I'm zooming out.
Clearly, somebody in this room murdered Lord Smythe, who, at precisely 3:34 this afternoon, was brutally bludgeoned to death with a blunt instrument. I want each of you to tell me your whereabouts at precisely the time that this dastardly deed took place.
I was polishing the brass in the master bedroom.
I was buttering his lordship's scones below stairs, sir.
I was planting my petunias in the potting shed. Constable, arrest Lady Smythe.
And this is just an example. Some of you may be familiar with gorilla video. There are many examples because the brain cannot process all the information. We always select a part of the information that is in front of us. And this brings me to the next concept of top-down information. Information gets into the brain, the input, the data, we call that bottom-up, but there are things in the brain already, our knowledge, our experience, our expectation, we call that top-down information. So the blue balls are the bottom-up information. It's the data coming into the brain. But we have top-down information, what we already know, and the top-down and bottom-up interact. What we see, what we perceive, our interpretation doesn't only depend on the evidence, but also what's going on in the brain. So you have the bottom-up. Yes, we do have information arriving from the retina, is processed, but we also have the top-down. Existing knowledge is used to guide information processing. This is not a bad thing. It's good. We're intelligent, right? We weren't born yesterday. When we hear something, we take it in a certain way based on what we know because we're smart. This is the core of human intelligence and expertise. However, it can also cause mistakes and biases because your perception and interpretation of the evidence is not only based on the evidence, it's based on other things. This is why smart people do stupid things. So that's a top-down processing. And the last concept in terms of a cognitive background is escalation of commitment. Once we make our mind up, yes, once we even have a theory, whether we're conscious or not, we believe this person is guilty. We believe the fingerprint match. We believe the handwriting doesn't match. Whatever, we already have a hunch, an intuition, a theory. For whatever reason, everything changes in terms of how the brain operates. We have escalation of commitment, we fixate, tunnel vision, mindset, belief perseverance, decision momentum, many technical terms. I don't have time to get into them. In everyday language, we talk about people double down or dig our heels in, or we rationalize. All of these are similar in the sense that once we see things in a certain way, we're not really open to going back. And what we do, we just escalate commitment. And unintentionally, it's not that we intentionally do it, we then pick out selectively information that helps us, pick out information that confirms what we believe already, and evidence that contradicts it, we just dismiss it, we don't see it. So that is the escalation of commitment, where we hold to our decisions, to our beliefs, and really don't consider alternatives. Even if there's evidence to support alternatives, we ignore them, discredit it, misinterpret it, a lot of mechanisms. And of course, that is extremely problematic if we don't want to hear, right? We don't want to hear anybody else. So remember, we don't want to hear anybody coming telling us we're wrong, because the police say we know the person committed it. We have eyewitnesses. He confessed to the crime, and you want to go and say, well, you know, you have the wrong person. The fingerprint doesn't match. The firearm doesn't match. The DNA, you know, they don't want to hear it. You don't want to hear it because you want to support the police and they want to like you. And when the initial decision and theory is in the wrong way, it's very hard to change because it's a very strong momentum. There are other reasons for that, which we can talk about later, that cause this escalation of commitment fixation, that we don't see the evidence for what it is, and that is a bias that can cause mistakes. Okay, now let's, this is a few things, just as a bit of background to the cognitive issues, that we have some insights where they come from, and of course, all of them are intertwined, and there are many more that I'm not going to be able to get into. Now I want to talk about specifically, I've done that already, but more in depth in forensic science, where do they come from, and how do we find them, expose them, and minimize their impact in forensic evidence? So where do they come from? We have these powers working and influencing the mind. The biases, the top-down processes. So you have the forensic examiner, she is looking at the evidence, whatever the type of evidence is, but then there's all these things that interfere. It's not a physical contamination of the evidence, it's a cognitive contamination of the perception and the interpretation. It can be something about the evidence, it can be something about the reference materials, base rate, contextual information, organizational factors, human cognitive, training, motivation, a whole bunch of factors, which each one I talk about for an hour or two, so I'll just give you a flavor, and again, you can read more if you're interested in the materials. But just about talking about this, we've made a huge jump. If you've taken this on board, it's a shift, because right now, we're not talking how good the evidence is, but we're talking about the decision maker. In the forensic domain, it's not the evidence that is important as much as the human decision maker. How do you take on board and perceive and interpret the evidence? And until I came to forensic domain to introduce this, people were talking about the evidence, and the evidence existed in isolation from the human element, from the human examiner, and the decision on the evidence, does it match, does it not match, what it means, doesn't depend only on the evidence, it depends more on the human examiner, and the human examiners and the factors that influence the perception and judgment that the forensic examiner makes. And this has been ignored. People don't teach it, people don't talk about it. When I read it, I get really, really angry. I say, I'm objective, I only look at the evidence. That is not the case. And these different factors I organize in a pyramid. On the top of the pyramid, we have case specific, something about this evidence, about this case that I'm working on, biases what I see, what I perceive, my interpretation and decisions. Sometimes the bias has got nothing to do with the evidence in this case. It's something about you, about the person doing the analysis, something about their personality, about their training, the environment they work in, the culture, motivation, ideology. And some things don't even depend not only on the case or the person doing it, but it's human nature. It doesn't matter what your culture is, what organization, what's your ideology, what's your personality, it affects all of us. Let me give you a few examples. So case specific, something about this case. So we've already seen and talked about examples that the evidence in this case, level number 3, may include irrelevant case information. So it's not the evidence driving it, the examiner gets irrelevant contextual information. So the fingerprint examiner, they can do a great job if their decision is based on the relevant information. What is the relevant information for a fingerprint examiner? It's a friction ridge. Do they need to know some context? Yes, they may need to know if the print mark was lifted off glass or off paper or of metal. What is the development, what chemicals or what powders would, that is relevant. But they don't need to know if there's eyewitnesses who identify the suspect as a murderer. They don't need to know if the suspect confessed to the crime. All of this is irrelevant contextual information, which unfortunately almost everywhere in every country, forensic examiners are exposed to things they don't need to. Even CSI, crime scene investigators, I join them in many, many countries. Everywhere I go, before they get to the crime scene, they're briefed, they're already told what is there, they're already told what happened. Why not let them look at the crime scene? The crime scene should decide if it's a burglary or if it's pretending to be a burglary for insurance fraud, if it's suicide, if it's homicide. No, before they get to the crime scene, if you recall the skeleton, deciding if it's a male or female, let them look at the skeleton, don't give them contextual information. So this is an example of the case specific. Level 3, irrelevant case information. Level 2, the reference materials. So what happens often when you compare? So you have, 2 cartridges in firearms, or 2 handwritings, or 2 fingerprints, or 2 DNA profiles, whatever it is, you have something, the actual evidence from the crime scene, and you have the suspect. What you need to do to be relatively objective and minimize bias is move from the evidence to the suspect. Don't go backwards from the suspect to the evidence. And that's what they do with the reference materials. They see the reference materials before they actually decide on the evidence. So they look at the fingerprint of the suspect or the DNA profile of the suspect, and then or simultaneously with the evidence. So the interpretation of the evidence is guided by the suspect. This is backward. This is making the suspect drive the cognitive processes, drive the decision-making, rather than what really needs to drive it, which is the actual evidence. So you need to start with the actual evidence. You do need the reference materials, but you need to make sure they don't bias the interpretation of the evidence itself. So this is just a few examples of a case evidence that can bias you. Then you have environment, culture, experience. So here the whole host of issues from the role of the forensic examiners. Many of them see themselves as supporting the police. Are you a scientist or a police officer? Forensic science is about the science. You're a scientist. Your role is not to help the police or not help the police. Your role as a forensic scientist is to scientifically look at the forensic evidence and based on the evidence, reach conclusions. But there's a lot of cultural issues. Many forensic laboratories are part of the police. It depends on your experience, on your ideology, on your training. It depends on the legal system in many countries, including most of India. It's an adversarial legal system. Do you work for the defense or do you work for the prosecution? You should work for neither. You work for science. But in the adversarial system, you work for one side or another. And we've done research where we find what we call the adversarial impact. We take the same evidence, the same exact evidence. We hired over 100 forensic experts, gave the same evidence to all of them, except we told half of them, you know what? This is the prosecution. This is the case for the prosecution. Can you look at the evidence? The other half, we said, we are from the defense. Can you look at the evidence? And we found huge impact. If they believed they were working for the prosecution or for the defense, they interpret the evidence differently. And again, we're talking about implicit bias. They didn't intentionally do it, but the fact that you're working for the defense, or you think you are, the fact that you believe that the skeleton is a male or a female, the fact that you believe that the fingerprint is going to match because the police officer said to you, the suspect confessed to the crime, or I know she committed the crime, all of this causes expectation that without your awareness, bias how you see the information and you don't feel it. And again, at the end, we have human nature, the cognitive system, the escalation of commitment, limited resources, top-down processing, things that are common to all human beings that have a brain, which is part of human nature and how the brain operates. Now, a few words of how to minimize it, because I do want to leave quite a lot of time for questions. So I will just give you a taste of the way we can minimize such things. So first of all, we need to remember that a simple takeaway message. Remove irrelevant information when possible. I'm saying when possible, it's not always possible, right? In fingerprints, you do not need to know if the person confessed to the crime or not. When you're comparing two cartridges from a firearm, you don't need to know if it's a murder case or not a murder case. Just compare, you look at the breech face, you look at the markings, and you make a decision. In those cases, it's very simple to dissociate and separate. Other cases are more complicated. For example, if you do voice analysis, so you can hear the screaming, you hear the content when you're actually listening to the recording. So sometimes you cannot do it, but many times you can. If you don't need the information, if the experts themselves said, I don't need to know if it's a male or a female when I decide if they're good enough to join the London Philharmonic Orchestra, then make sure they don't see it, that they're not exposed, so they make the decisions based on the relevant information. If you look at the goddess of justice, right, the image here, she had a scale, a physical scale of the evidence, but even then they had the wisdom, more than many forensic crime labs, that you have to be blindfolded. Look at the statue. The goddess is blindfolded because they already understood then that when you see the evidence you're considering, then it may impact how the scale works. If you want the scale to actually work on the evidence, you don't want to see irrelevant information. You want the science and the evidence. And when you go out and when you're going to be forensic examiners or police investigators or criminologists, when you make decisions or when you look at decisions made by others, what did they know about the case? Did they know irrelevant information? And then most often they do, you get the potential of bias. Of course, they're going to deny that it impacted them. They're going to get very aggressive, defensive, because they don't feel it. What's important is to have proper blind mechanisms. We want, when you weigh the evidence, we don't want them to see things that they should not see. And we do it many times where we look at evidence that, forensic examiners verified it and did confirmation and everything, reached the conclusion. We take the same evidence and we give it to other forensic examiners, but this time we don't give the context. We don't tell them the person confessed to the crime or whatever, and they reach different conclusions. It's very important not to have them exposed. The problem is also when you have good blinding mechanisms that they don't pick, because many times you have procedures around the world are implemented now more and more that ensure that forensic examiners only get the relevant information. However, when they go to have coffee or tea, or they go and play football or cricket in the evening, they talk to one another, and there's a lot of informal discussions. Now, there is a problem, I was just mentioning, deciding what's relevant or not. Who is going to decide it? We don't want the police or someone who doesn't know. So one way of doing it is what we call the case manager. So in the forensic lab, the case manager, she gets all the information, including irrelevant information, everything, and she decides what's relevant or not. But then she does not do the forensic analysis. She gives it to another examiner and gives the information that they need in order to make the most objective decision, not exposing them to irrelevant information. So that's one kind of solution. One more, and this is the last one that I will mention so we can have a bit of questions and discussion, is linear sequential unmasking. LSU. LSU, linear sequential unmasking, is a context management toolbox. It's controlling the sequencing and the timing, who gets what information in what sequence. You remember I said to you, we want to make sure that the evidence is driving the decision, not the reference materials. So linear sequential unmasking in DNA, for example, and we have a number of papers on it, says the DNA expert is not allowed to see the profile of the suspect until they fully develop the DNA from the crime scene, and they can decide on stutter and drop allele based on the evidence, not based on the profile of the suspect, because then they do it in a way unconsciously to match the profile of the suspect. And the same thing with firearms and handwriting and any kind of comparative forensic. When you have patterns, you want to start with the evidence and then move on and compare it to the suspect. Linear sequential unmasking is aimed at making sure that the evidence, the data, is driving the decision-making process. We want to avoid a target, a hypothesis-driven bias, working backwards. We want to avoid this cognitive contamination by the target. Here is the suspect, and our target is to match this evidence to that suspect, to that target. That is the wrong way to do it, which is often done, which biases the interpretation of the evidence to meet the suspect. Get only the relevant information and get it when you need it. so you base it on the relevant materials. That is a linear sequential unmasking. So we've looked at what is cognitive bias, where the problems come from. We've seen a few examples of its effect. Again, just an illustration to give you a taste of what I mean by cognitive bias and how it can affect forensic science in the interpretation of the evidence. This is how the brain works, and there can be solutions if we acknowledge the problems and take it seriously. So now it's going to be times for your questions. Thank you very much.
We can take some questions. Is anybody is having a question? They can post the questions in the chat box so that the questions can be delivered to sir and sir will answer. Sir, we have one question from our YouTube link by Miss Tanya Datta. She's asking that how does one come to know whether it is a male or a female skeleton? If it is a case of unknown skeleton, can we determine the gender on the basis of that? And what thinking process we as a human being undergo with that?
Well, whether you can determine if it's a male or female skeleton depends on the skeleton, depending if it's a fragment, if it is a full skeleton, if you have the pelvic, if you can measure it, if it's clearly a male, clearly a female. It depends on the evidence on the actual skeleton. Often you can do that, sometimes you can. It depends on the quantity and quality of information. The same thing with firearms and fingerprints and DNA. It depends on the quality and the quantity of the information. The point is that I want them to determine that it's a male or female skeleton based on the skeleton, not based on the police detective saying, we know the woman who was kidnapped and raped and her body disposed in this area, and we think we found her skeleton. Because then you're already expecting a female skeleton, and you may misinterpret what the actual skeleton tells you. What the actual skeleton tells you depends on each case. It may be different or not. And if you cannot say if it's a male or female skeleton, that's okay. Then you say, you know what? I cannot say if it's a male or female. But when you say it's a male or female because you heard the background story or you expect to find the skeleton, and you say this is only based on the skeleton, where actually the skeleton is not enough information to make the decision, then you're biased and you're misleading the court. And this is what we want to minimize and avoid as much as possible.
Okay. Thank you, sir. We have some more questions. We have one question from Mr. Gyanoji Dalvi. He's asking about what's the role of perception in bias framing.
Well, framing is very strong impact, and framing is how the questions are posed. So when the police require a forensic examination, then we looked at the way they do it in the form. So one issue is the information contained in the request. And many times they tell you the gender, the race, whether the suspect had a criminal record. But they also frame the questions in a certain way. And the way you frame the question and the data impacts two different things. One, it impacts the perception, what you observe and what you see. Number two, it impacts your interpretation of it. So this framing and contextual information, the bias that it creates can impact the perception, the observation, but it may impact the interpretation. Of course, it can impact both of them, but most time we think it impacts the bias, how you make judgment of the evidence. It also impacts what you see in your perception of the evidence. So the framing is very, very critical to get it as objective as possible, not to plant ideas in the forensic examiner, we just finished a survey. We're going to publish it in the Journal of Forensic Science. It's been accepted, where most forensic examiners say that in many cases, before they look at the evidence, they are told what they're expected to find. So they're framing it and telling them what they're supposed to find before they look at the evidence and creating an expectation. We want the evidence, the forensic science evidence, to drive the decisions and the perception.
Thank you, sir. There is one more question from Mrs. Sharda Avadhanam. She's asking that in this age of automation, the machine generates the missing information, how it affects the bias of examiner. Also, she is asking that how quality assurance and accreditation minimizes this bias.
Okay, so quality assurance and automation can be very powerful tools to combat bias, but they can also be ways to hide bias and make it look like a bias is not there. So for example, I'll give you an example of each. Automation, many times this automation, the technology, doesn't come from God or the sky. It's programmed by people. So many times the bias is in the technology, it's in the automation, it's programmed in the automation, but now it's hidden in the automation. And people say, well, I used a software that does face recognition, but face recognition software has biases. So that is one example with technology. With technology, we also have the issue that the human has to interpret the results of the technology, and the human has to determine the input. So in fingerprint, we have AFIS, automated fingerprint identification systems, which are quite good, but the human has to tell the machine, the automation, what are the minutiae, what are the relevant details of the evidence that are important. And that's a human judgment, and we have research and papers, again, if you go to the webpage with the links, showing how the human perception of what the data is and what they give the automation depends on their expectation. So these are just a few examples of automation. Quality assurance, again, can be a very good tool, but often quality assurance is a rubber stamp, box ticking, and not real quality assurance. So quality assurance and accreditation can be very powerful tools in minimizing bias, in making sure there is training and there are procedures to combat bias, but they don't necessarily do that. So technology and quality assurance and accreditation are very good tools if they're used properly. But if, it's only two letters, if is the biggest word in English. So it can be used, but also misused. So the devil is in the detail. To use proper technology and proper quality assurance, then we can move forward.
Thank you, sir. We have another question from Mr. Raghavendra Prasad. He's asking that, is there any general cognitive model exist in order to prevent high impactful officials from becoming vulnerable to bias?
There are many cognitive models, and when you're talking about minimizing bias, many times they don't want to minimize the bias. The bias serves them very well. They're self-serving biases. So many people have a lot of self-serving biases and hindsight bias. So first of all, we need people to acknowledge that bias exists, number one. Then after we acknowledge that bias exists, we need to agree that we need to minimize the bias. Once we agree on that, there are many models. For example, I presented the bottom-up versus top-down processing, where we know that the top-down processing, which is an effective brain cognitive model that helps us perceive and interpret information, can cause us to go in the wrong direction, and then we can apply it to minimizing bias. But I want to emphasize that bias impacts hardworking experts, and B, I only talk about minimizing bias, not about eliminating. We cannot eliminate bias, but we can definitely considerably reduce the bias.
Thank you, sir. Um, so next question is from Drashti Parmar. What would be the best approach to avoid initial cognitive bias about a famous case? For an example, a case uh, where media is involved so much, should a particular evidence be circulated to many forensic experts? And does it add some bias towards the evidence since initial details of the case is available openly to everyone, including forensic experts? Thank you.
That's a very good question. When it's a famous case, it's a big problem, right? Because everybody knows about it. Everybody is reading in the media, including the forensic experts. By showing it to many experts, you're not getting better, because if all of them are exposed and all of them are biased by the media, then it doesn't matter. It's you doing the same thing. It's like, buying a newspaper and you want to make sure that it's correct. You buy more copies of the same newspaper. It's going to say the same. You need a different newspaper, a different perspective. So ideally, you can find examiners that are not exposed to it. You may have to go far away to do that, depending how famous a case is. But if you look, for example, in the United States, when they have quite a lot of cases of white police officers killing, shooting unarmed black men, and you have the forensic pathologist examining the bodies, knowing that it's a famous case, it's all over the media, there are videos showing what's happening, there's a lot of testimony. When we want the forensic pathologist to focus on the body, right? There are 2 bullet wounds, one in the front, one in the back. And the forensic pathologist needs to determine what is the entry and what is the exit bullet hole. The entry is going to be smaller, the exit is going to be bigger, the way the skin turns. But if they hear different stories from the media that the police officer shot him in the back as he was running away, or that the suspect was running towards a police officer and the police officer in self-defense, it's very hard to isolate them. And there is a basic problem in famous cases all over the media. That is a very big problem. The only thing you can do is try to find experts who have not been exposed to the media, and you may have to go very far away to maybe a different country to do that. Another way to do it is what we call lineup evidence. So even if they know it's a very famous case and there's a fingerprint from murdering, the king or the prime minister or whatever is in the media, when they do eyewitness lineups, they know when they have a suspect, they cannot show the victim, the suspect, and saying, is this a person who tried to rob you? What they do in eyewitness lineup, they show a bunch of people, there's a lineup, maybe even 10 people, 9 of them are not the suspect, and the suspect is one, and they ask the eyewitness, can you identify from this 10 who is the person who attacked you? The similar you can do with forensic evidence in famous cases. You can do a lineup of evidence, and again, we have done that in fingerprint and other domains. I can send you the paper, where instead of giving the examiner, here is the fingerprint of the gun that shot the prime minister, and here is the fingerprint of the suspect. Can you match it? They know. You say, well, here's the fingerprint that shot the prime minister. You can't avoid it. It's in the media. But instead of showing the fingerprint of the suspect, you show 10 people. You show fingerprint from 10 people. One of them is a suspect, and 9 are decoys, they're distractors. So even though they know it's a famous case, they don't know which one of the 10 is the actual suspect, like they do in eyewitness police identification. So there are solutions. The problem is not the solution. The problem is that forensic examiners deny the impact of bias. They say we're objective, we're not infected or affected by the fact that it's a famous case or we know this or that. That is the problem. Once they acknowledge that they may be biased, the solutions, we can come up with solutions. The solutions are there. The challenge is not the solution, it's acknowledging the existence of bias in forensic science.
Thank you, sir. There is one question from Dr. Rajesh Verma. He asked that we get a lot of context-sensitive information in cases, and experts may be prone to bias. So, what can be the first step to start this unbiasing process?
Okay, so this question is already someone who is 2 steps ahead. That is good. What can be done is minimizing exposure to the information. So you do not want to be exposed to context sensitive. So A, are you able not to be exposed to it? Are you able to take steps not to know, for example, if the suspect that you're comparing the firearm or the DNA, do they have a criminal record or not? Knowing if there's other evidence. So are you able to filter out, to blind that information like they do in placebo and double-blind experiments, in many domains, they have these procedures. That's A, simple. B, if you cannot do that because it's given to you and all the information, is to use a case manager. When you get all the file, is before you do the judgment on the forensic evidence, give it to another forensic examiner and say, can you go over the materials here and give me only the relevant? So you have a case manager or someone who filters out, takes out the contextual, sensitive, irrelevant information that may bias you, but you do not need in order to perform the task. The forensic decision is irrelevant to information like if the suspect confessed to the crime or not. So you want to do all of that. C, and this is the last one, but there are other ones. C, you want to make sure that the evidence is driving the decision making. So do linear sequential unmasking, LSU. When you get the DNA profile of the suspect, you get the DNA from the crime scene, you get the firearms and so on. Start with the evidence itself. Don't look at the handwriting of the suspect. Don't look at the fingerprint of the suspect. Take the actual evidence, the handwriting, the fingerprint, the firearm, whatever evidence it is, and look at it before you see the suspect, before you see the target, and look at it, characterize, write down, what do I see? What are the characteristics of the handwriting? The I has a dot or doesn't have a dot. The angle of the L and the loop in the L is especially big or small, or whatever features, the minutiae in the fingerprint, or whatever domain you're looking at. Look at the characteristics of the actual evidence and document them. After you do that, only then allow yourself to see that of the suspect and to do the comparison. These are a few examples. Of course, there are many more.
Thank you, sir. There is another question from Ms. Shreya Rastogi. She's asking that in India, the forensic science laboratories have to work with the police departments, and the police people, they are sending many case papers to them for studying and consulting, but they don't have any case managers over there. So in these issues, how the cognitive bias can be dealt with?
Well, the fact of the matter is, in most countries, the forensic examiners work very closely with the police. Not only they work very close with the police, they are part of the police. They see the role as supporting the police. Now, you have to distinguish two kinds of modes where the police approach a forensic examiner. One approach, which happens, is a police officer comes and a police detective, he says to you, look, there's been an armed robbery or a murder case, and I have no idea who committed it. Here is the relevant evidence. Can you help me? Mode 2, that happens also quite a lot, they come to you and she says, I know who committed the armed robbery. Here is the person who committed the armed robbery, and I need you to help me establish it. I'm building a case against this person, and here's the forensic evidence I know who committed it. In the first case, they are using science to solve the case. Great stuff. In the second case, they're misusing and abusing science to help them. They really don't care what you think. They just want you to support what they already believe, and they don't want to hear anything else. In the first case, no problem, take the relevant information. In the second case, I don't want you to get in trouble and be rude, but I'm a very direct person. I say to them, if you already know who committed it, if you already solved the case, why are you bothering me? You don't really want to hear what I have to say. But again, it depends. If you're paid by the police in a crime lab, you don't want to get fired. And this is back to the sources of bias of organization. In many places, it's not only the forensic lab is part of the police. In many places, the forensic examiners are police officers. They're part of the police. They wear uniforms. They're police officers. So their loyalty is to the police. And then you get a very hard problem. How do you do science when you're part of the police? The police is not scientists, and we want to bring science, and that is not an easy thing to do.
Thank you, sir. We have one question from our respected director IBS from Gujarat Forensic Sciences University, Brigadier Tripathi, sir. He has asked that in behavioral sciences, the use of polygraph or other techniques requires information about the perspective to frame questions. So how do you propose to minimize the bias here?
Well, polygraph is an interesting case. In some countries, it's not admitted in court. In some countries, it is admitted in court. In some countries, the judge can order polygraph. Polygraph is extremely problematic, not only because you need context, as you correctly say, how to frame the questions. You need to ask about the case, right? You're not looking at the fingerprint or firearm. You need to ask about the case. You need to know about the case. And you can try to frame the questions as best you can. But the problem with polygraph is much larger. In a polygraph, the person conducting the polygraph actually sees the suspect. They see the race, they see what sex they belong to, they see are they attractive, do they stink, do they smell, are you in prison? All these factors are exposed to the suspect, which influences them. You can't separate it. What you could do is that the person conducting the polygraph examination would not be the person interpreting the polygraph. I call that compartmentalization. You want to compartmentalize so you don't get bias cascade. It's similar that in many forensic domains and police forces, the crime scene investigators that go to the crime scene and collect the fingerprint is the same person who goes back to the lab and does the analytical comparison of the fingerprints, and then things they see in the crime scene cascade to the lab. And what I always suggest is to cross, so the fingerprint examiner in the lab, they do comparison of fingerprints from other crime scenes, not ones that they went to. The same thing in polygraph. It will be good if one person has to be exposed to information. You can't avoid polygraph. They need to know, because they need to know to ask the questions. They can try to do it objectively. And this is a whole lecture on polygraph and a workshop, how to frame the question with minimal bias. But once they ask the questions, once they get the polygraph data, rather than that person interpreting the polygraph, the person who was exposed to the suspect, the race and all the other information, they need to give it to another polygraph examiner to look at the polygraph results and interpret them more objectively, because they have not been exposed to the person, actual person, suspect, who they asked questions during the polygraph.
Thank you, sir. One more question from Mr. Neeraj Khandelwal. He's asking that how do we decide which information is relevant for the specific case to get rid from it? Because half of the population see the case from the prosecution perspective, and half of the population sees the case from the defense perspective. So your comments, sir.
So the allegiance effect of the prosecution and defense perspective is absolutely right, and I talked about it. However, there are things that are so basic that the scientists say themselves is irrelevant, and every domain is a bit different, but the examples that are never relevant, it doesn't matter if you're the prosecution or the defense, it doesn't matter if you're DNA or fingerprint or firearm or handwriting or toxicology. Did the suspect confessed to the crime? Are there eyewitnesses identifying the suspect? Does the suspect have a criminal record? The people who are looking, the forensic examiners who are expert in forensic pathology, they're expert in fingerprinting and DNA, this is irrelevant information. When you go to the fingerprint examiner, you ask her, when you compare the two fingerprints and decide if it's a match or not, what do you look at? And she can say, I'm looking at the friction ridge at the level 2, at level 3. Is the way you look at the fingerprint different, whether you know this suspect has a criminal record or not? they would say to you, no, that's not relevant. It may be relevant for the judge. It may be relevant to the juror. It may be relevant to the police investigator. But the forensic scientist, the fingerprint expert, is an expert on fingerprint. Only fingerprint evidence is relevant to them. And the same with DNA and firearms and domain after domain. And we've asked, and every forensic domain have started to list what is the relevant information for you to make decisions in your domain, and anything else is not relevant to them for making the forensic science decision. It's important for the prosecution and the judge and the detective, but not for the forensic scientist doing science based on the relevant evidence.
Thank you, sir. One question from Mr. C. Rajesh. He's asking that, is there any LSU approach studies made specifically on forensic handwriting identification? Can you suggest him some sources?
Drop me an email. We have on DNA, we have on some domains on handwriting. We have a paper what we submitted, which is under review right now, on specific about bias and reliability in handwriting. If you drop me an email, anyone, I'm happy to send you papers and copies of the slides. So just drop me an email. I see some people are leaving the email in the chat board. I'm not going to be able to see that. Drop me an email with your email and I'll send you papers and all the slides or whatever you want.
Thank you, sir. There is one question on the YouTube link from Mr. Deepak Midha. He's a Deputy Director, CFSL Chandigarh. He's asking that which type of bias happens when a forensic scientist come to a conclusion before all the evidence are being processed?
Well, I fear this bias is very, very common, where they reach a conclusion before they go over all the evidence or some of the evidence. And that kind of bias, that to reach a conclusion not driven by the evidence, can come from different sources. It can be confirmation bias. It can be motivation bias. There are different biases. The biases are the brain and cognitive mechanism that lead you to reach a conclusion prematurely. Now, the reaching a conclusion prematurely before you go over all the evidence or any of the evidence or enough testing is the result of many different biases. And each bias has a bit of a different mechanism that is involved in that. So there isn't one bias, because the bias is the actual mechanism, and what he's asking is the result. And the result of reaching a conclusion not based on the evidence or before you looked at all the evidence properly is the result of very many different biases that can cause that.
Thank you, sir. There is another question from Mr. Harry Joshi, which he's asking that how can we relate police psychology and human cognition bias?
So police psychology and police bias is a very different topic, because police have biases, and police, like everyone, judges have biases, jurors have biases, you know, you're biased, I'm biased, we all have biases. But at least the police officer and the medical doctor, they don't misrepresent themselves. The police detective, she would never say, I'm objective. She would never say, I never make mistakes. The problem in forensic science is not only the bias, the problem is a bias blind spot where they don't acknowledge it. They believe they don't make mistakes. They believe they're objective, and then they go to court and misrepresent unintentionally, but they're misguiding the court because they're giving the evidence more strength that it needs. They're presenting themselves as scientists, as objective scientists. The jurors watch too much CSI on TV, so they have unrealistic expectations. So the forensic examiners are, I would say, less biased than the police, but their bias is more dangerous because it's more powerful in the court.
Okay. Thank you, sir. One last question we'll take for the today's session. It is again by Mr. Deepak Midha. He's asking that, can you suggest some measures to protect quality control against the bias?
Okay, so I'll suggest one. And again, in the paper, we have lists of measures and data. quality assurance, for example, verification, is not blind. So the verifier of a decision in a fingerprint, firearm, DNA, whatever the domain is, when it goes to verification, they know everything. So they know who made the decision, they know what decision they're verifying, they know all the information rather than looking at the evidence, not knowing. So they get and say, oh, this examiner already determined this is a match. Do you agree? This examiner already determined this or that. So if you want to have quality assurance that is more powerful to bias and other potential errors that are not caused by bias, because bias is not the only cause for error in forensic decision making, you want to make sure that the quality assurance, the verification are blind. The person doing the verification does not know who made the decision or even what decision was made. They look at the evidence, reach the decision, and then they see whether they reached the same decision as the first examiner. That makes it much more involved and less biased.
Thank you, sir. Any other questions from the house, please?
So,
Surbi, your voice is fiddling. Surbi. Okay.
Can you hear me now? Can you hear me now?
Yeah.
Okay. So, thank you, Dr. Dror, for an amazing and enlightening presentation on the right way to account for cognitive and human factors in forensics. We appreciate having taken us to the mysterious and uncharted path and clouds of doubts clarified. The critical elements of decision making and the prompting factors will benefit us all, and especially the forensic practitioners from laboratory setup who have joined us today in the large number. We are grateful to you, sir, for agreeing to conduct this webinar and to be amongst us. Please accept our sincere thanks for your valuable time and laudable efforts. Thank you so much, sir. Namaste. Jai Hind. Thank you, everyone.
Thank you. Thank you.
I also thank our Honorable Director General, sir, Dr. J.M. Vyas, sir, to join this meeting and sparing his valuable time. Also, Director, Institute of Behavioral Sciences, Dr.